Computer Science, Cambridge Institute of Technology, Bangalore. Today I will be teaching you what is arrays in C language. What is this arrays? From where I pick this arrays? And what role the arrays will play, what type of arrays we have, how to use them in a program. Today I'll be teaching. Now I'll start with arrays. Basically, we have already studied C supports three different types of data types. One is fundamental data type, derived data type, and user-defined data type. In fundamental data type, we have studied already integer, float, double, and character. And already we know that how to use them. Where in case of integer, it takes 2 bytes and it supports how many variables you want, you can declare of type integer. Float supports real numbers. Double again supports when you have a more precision number, then we are going with a double. When you want to use a characters, we are going with a character data type. Similarly, we have a derived data type. In that, we have arrays. Why we need these arrays? What are these arrays? Array is a derived data type. As I've already said, array is a derived data type. It is used to store when I have a collection of same type of data items. I can group them under a single name, and this occupies continuous memory locations. What is the exact meaning of it? For example, if I want to declare 100 numbers, then I need 100 variables. So how I'll be declaring? For example, I can declare like number 0, number 1, number 2, number 3, number 4, up to number 99. But instead of doing this, I have a concept of creating an array variable, only number. And I can use it as number of 0, number of 1, number of 2, and up to number of 99. To represent each number of 0 will represent the first element, number of 1 will represent the second element, and so on. What is this 0? This 0 indicates it's a index. This index is an integer positive number that starts always with 0. Now we'll see what are these arrays. What is the meaning of continuous memory location? If I have a n number, and a number is a array name, and I have n numbers. I don't know how many numbers I have. The first element will be numbers of 0. The last one will be n. Whatever the last number you have given, that will be the last. Always the memory will be allocated continuous. In the sense, the first memory location will be given for number of 0 and keeps on allocating the memory. The last element will get the last memory location address. Now, where we are using this array concept? In case of list of employees in an organization, if you want to get the list of customers and the telephone numbers, if you, for example, you can consider a list of students, university numbers, and their marks, then we can use concept of arrays. Now, how many types of arrays are there, and C supports how many types of arrays? There are basically three types of arrays. One is one-dimensional array, two-dimensional array, and multi-dimensional array. When we have only one line of data, then we can go with one dimension because the data is just in a row. So I can go with a one-dimensional array. When I have a tabular data, rows and columns, then I'll be going with two-dimensional arrays. When I have more dimensions, then I'm going with a multi-dimensional array. Now I'll consider one example. I have given certain numbers 20, 12, 34, 56, 78, and 28. These are the numbers. First, how many numbers are there? 6 numbers are there. Then I have given a name num. I have grouped them under a name num. Num is a variable and we call it as a array. Now the num of 0 will be referring to 20. Num of 1 will be 12. Num of 2 will be 34. Num of 3 will be 56. Num of 4 will be 78. Num of 5 will be 28. Here, always index starts with 0 and ends with maximum size minus 1. Because we are starting with 0, so obviously it will be n minus 1. Now we'll start with one-dimensional arrays. What are this one-dimensional array? When we have, I said, a line of data or a linear list of data items of same data type. If I want to group integer, all must be of integer data type. If I have a float, all the values inside that array must be float data type. If I have a character, all the values inside that must be character data type. It's a linear list of data items of same data type which are stored continuously in memory is called one-dimensional array. Now, what is the syntax? Data type, name of the array, and size of the array. For example, float is a data type, height is a array name, and I have considered 50 students. So total data, how many values are there? 50 values are there. What it does, declares the height to be an array containing 50 real elements. Any subscript starts from 0 to 49 are valid subscripts. Consider another example of type integer, and I have only 4 numbers. I have grouped only 4 numbers. What it does, it declares the number to be an array containing 4 integer elements. Subscript starts from 0 to 3. Now, how does the memory will be allocated for this one-dimensional array? I'm considering a declaration int number of 5. The meaning is I have an integer grouped 5 numbers under a name number. How the memory looks like? First, number of 0, memory will be allocated. Then number of 1, number of 2, number of 3, number of 4. So the continuous memory location will be allocated. If I'll put number of 0 equals to 10, then I'm assigning number of 1 equals to 20, number of 2 equals to 30, number of 3 equals to 40, number of 4 equals to 50. I have just assigned the values. Those values will be placed like this. First, number of 0 will be assigned with 10, number of 1 will be assigned with 20, number of 2 will be assigned the value 30, number of 3 will be assigned value 40, and number of 4 will be assigned value 50. Now, memory allocation. What formula we are using? Total allocated memory. How much memory an array takes? A one-dimensional array takes how much memory? Size, that is the array size, into the size of a data type. If I'll consider integer, it takes 2 bytes. If I'll consider a float, it takes 4 bytes. If I'll consider character, it takes 1 byte. Now we'll see one example. I have made a declaration integer number 5 number 5. That is, I have grouped 5 numbers of type integer. So total memory location allocated, total memory space allocated for this declaration is, what is the size of the array? 5 into the size of integer. What is the size of the array? 5. And what is the data type? Integer. Now, size of array is 5, size of integer is 2, so total it is 10 bytes. If you want, you can try for these also. Float, height of 6. How many elements? What is the size of array? 6. How many elements are there? 6. Into size of float, that is 4. 6 into 4 is equal to 24. And you can try for this also. Character takes 1 byte. How many characters are there? 8 characters. Into size of character is 1. 8 into 1 equals to 8 bytes. Now, last example, you can try this also. Int number of 20. Size of array is 20. Size of integer is 2. 20 into 2 equals to 40 bytes. Now we have understood how much memory space it is going to occupy on in the system. Now we'll understand how this memory will be allocated. How much memory I said. Now how it will be allocated, we'll see one example. I'll consider integer declaration, integer number of 4. That is, I have declared an array number with 4 elements. If the starting address is 8000, first we'll calculate how much memory space it needs. 4 into 2 equals to 8 bytes. This 8 byte memory, how it will be allocated? For that we have a formula, address of an element. I want to know the address of a particular element. Starting address you have to give plus index value into size of data type. I'll consider I want to find out this number of 2. That is third element I want to find out. On what memory location the third element is stored. Starting address is 8000 plus index is 2. I have taken from this. Index is 2 into size of integer. Size of integer is 2. 8000 is the starting address. 2 is the index and 2 is the size of integer. On 16-bit machine, it is 8004. On 8004, we have a number of 2. You can see here on 8004, I have number of 2. For the declaration, integer, number array of 4 elements. The name of the array is number. Now on 8000, starting address is 8000. First element will be stored 8000 plus 2, 8002. The second element will be stored 8002 plus 2, 8004. The third element will be stored, and 8004 plus 2, 8006. The last element will be stored. That each time it will be incremented by 2 bytes depending on the how much bytes each value will occupy. If it is integer, 2 bytes. If it is float, 4 bytes. Now we'll take another example. Now I'll take an example of float data type. In this case, I have made a declaration. Number is an array of 4 elements of type integer, floating point. Now, what is the memory layout of this? Starting address is 8000. First value will be stored at location 8000. Second value will be stored at location 8004 because float takes 4 bytes. So 8000 plus 4 equals to 8004. Next element will be stored on 8004 plus 4 equals to 8008. Next element will be stored in the location 8008 plus 4 equals to 8012. So it is a continuous memory location. Now I'll go with an example of character data type. In this case, how the memory layout looks like. First element, that is name of 0, will be stored at location 8000. Each will take only one byte. So name of 1 will be at location 8001. Name of 2 will be at location 8002 because it takes one byte. 8000 plus 1 is 8001, plus 1 is 8002, plus 1 is 8003. In a character data type, whenever you give a character array, the last one must be marked with a null character. The /0 indicates it's a null character. That indicates it's the end of a character array. So any character data type, if you are using, then you have to mention this null character. We'll understand it when we'll be studying the strings. We'll go with how to do the declaration of one-dimensional arrays. What is the syntax to declare one-dimensional array? Now, what is array? Array is a group of similar data type of values. We are grouping them under a single name, and this will occupy continuous memory location. Here, now, what is the syntax? Data type, name of the array, and the size of the array. How many elements are there? Example, integer is a data type. A is the array name. How many elements are there? 10. 10 is the size of the array. 10 is the size of the array. What it does, it declares A as an array to contain maximum of 10 integer constant. Similarly, I have taken one more example, character, name of 10. What it does, this declares the name as a character array variable that can hold a maximum of 10 characters. In this 10 characters, it includes null character also. Previously, I have just explained null character is used to mark the end of the character array. It includes, this 10 character includes that null also. Now we'll understand how, once the declaration is done, we have to assign the values to the locations. How it is possible? In what way I can assign the values? We call a concept of initialization of one-dimensional arrays. While declaring, if I'll assign the values, initial values, we call it as initialization. We can do initialization of arrays in 2 ways. One is at compile time, another one is at runtime. At compile time, we'll see compile time initialization. In that, the first one is full initialization. The syntax is type, data type. It can be any of the basic data type, and name of the array and the size. And you can assign the list of values, grouping them in a flower braces. The values in the list are separated by commas. Example, I'll make a declaration of integer a of 3 equals to 11, 20 and 3. I'm grouping 11, 20 and 3 in a flower braces. A of 0 will be assigned 11, A of 1 will be assigned 20, A of 2 will be assigned 3. I have already shown here A of 0 will be assigned 11, A of 1 will be assigned 20, A of 2 will be assigned 3. This is called whatever the size I'll say, those many values I'm giving here. Whatever the size I will mention here, those many values I'm giving here. The syntax is in the data type, name of the array, size of the array. Whatever the size I'll mention, those many values I'll group in a flower braces and I'll separate them using a comma and ends with a semicolon. This is full compile time, full initialization. Now we'll go with the partial initialization. Here what I'll do, I have given an integer declaration. I made an integer declaration for 5 numbers. I said array size is 5. Fine, but what I have given here, only 2 values. What about the remaining? First 10 will be assigned to first one. 20 will be assigned to second one. What of the remaining? Remaining will be filled with values zeros. If it is integer, it will be filled with zeros. What if I'll take a data type character, city of 4. I said city has 4 characters including null. City has 4 characters including null. Now how many I have to give? At least minimum 3 I have to give, right? But how many I have given? Only 1 I have given. Only a partial part of the array I have given. What about the remaining? First one will be filled with B. The remaining will be filled with null values. Clear? Okay. We'll go with the next one. That is compile time initialization, but without mentioning the array size. What I have done here, integer, name of the array is A, and I have not mentioned anything, no size. I have given values. What the compiler does here, it counts the number of values you have given. Here, how many values I have given? 1, 2, 3, 4, and fills the array size. And fills the array size as 4. Fills the array size as 4. And here, all the locations will be initialized with the value 1. Now, this approach is used when you want to initialize each and every element in the array. When you want to initialize each and every element in the array, then go with this type of array initialization. Now, example here, character C of size I have not mentioned. I have given 1, 2, 3 A's I have given. How much, what will be the size? Size will be calculated as 1, 2, 3 plus 1 for null character. So the size of a character will be, array will be 4 here. Even though I have given 3 values, but it will be considered as 4 because each character array ends with a null character. Now we'll go with the next one, that is with specifying a character constants. Now I have made a declaration here, character name of no size. I have not mentioned any size here, but I have grouped the values inside the flower braces. Let me count how many values we have given. First one is 1, 2, 3, 4. And the last one to indicate it's the end of the array. So total how many are there? 1, 2, 3, 4, 5. The size of the array will be 5. Size of the array will be 5. And the memory will be allocated like this. The locations will look like this. Name of 0 will be J. Name of 1 will be O. Name of 2 will be H. Name of 3 will be N. And the last one will be allocated with null character. This is with a character constant. What about the string constant? The last method of compile time initialization is with string constant. That is, I have made a declaration of type character because string is a character data type and name is a array name. Size I have not mentioned. What it compiler does, it starts counting the number of values 1, 2, 3, 4, 4 plus 1. The difference between a character constant array and the string constant is, in case of a string is anything enclosed in a double quote. In case of a string, null will be attached by the compiler. Null will be given by the compiler. In case of character array, null you have to mention. If you are giving by character, null you have to mention. If you are giving by string, null it will be given by the compiler. That is the major difference between a character array and the string constant. Usually we will come across with such mistakes. The first mistake is, I made a declaration. I said 3 numbers of type integer, but how many numbers I have given? Count 1, 2, 3, 4. Here, compiler produce an array. Compiler will give you a error message that you said 3, but you have filled 4 values. So one value doesn't have a space here where to be located. So a compiler will give you an error. Another major mistake, what we will do is float number of 11.3. Always I said the size of array, the index must be of integer type, positive integer type, but we have given here float. It is not possible to show the location. So even in case of int number of 10 2, even this is a real number, so for such things we cannot allocate a memory. So these are will be compiler will produce a error. Usually most of the people who are declaring or are using arrays for the first time, they'll do this mistake. So these are the mistakes, we'll not do these mistakes. Now we'll go with the runtime initialization. One way you have understood, while declaring itself, I have assigned the values, the proper locations, the values will be stored. If I'll miss the size, how the size will be counted by the compiler, how the values will be assigned. If I'll give the full size and the full values, how it will be assigned. If I'll do a partial initialization, how the initialization will be. Everything you have understood. Now we'll go with another concept that is called runtime initialization. In a runtime initialization, when I declare int a of 3, only declaration I have done. What will happen? 3 memory locations will be created, a of 0, a of 1, a of 2. Each will be of 2 bytes because it's an integer. It's blank. Nothing is there. Nothing is there. Now, one way of filling these blocks, these values, is enter 3 numbers. Because I said here 3 numbers, so I'm asking here 3 numbers. So read them as, first scanner function will scan the whatever the values you have entered, and it takes one by one and assigns 3 values. Said how many values to scan? 3 values to be scanned, and 3 values will be placed. The first value will be placed in ampersand a of 0, address of first location. Second value will be placed in address of second location. Third value will be placed in address of third location. So you are placing the values. Fine, this will work. What if the array size is 30? How will you read? How many percentage Ds are required? 30 percentage Ds are required. How many addresses you have to give? 30 addresses if you have to give. As the array size increases, the reading values, the size of the scanf function will also increase. This becomes very tedious as the size of array increases. Another method to do the same work is this. I have declared here two variables. One is I, another one is array a of 3. I will ask again, enter 3 numbers. This time, I will make use of a for loop. I will start a for loop, I equals to 0, I is less than 3, because I said 3. So I have to write 3 elements. Only you read 3 elements and I plus plus. What I'll do when I value is 0, I'll scan the first value and I will place it in first position, a of 0. I will be incremented. Again, I becomes 1, 1 is less than 3. I'll read the second value, I'll scan the second value and I will place it in a of 1. A of 1. Again, I will be incremented by 1. Again, 2 is less than 3. I'll scan the third value and I will place it in the address of a of 2. Are you getting? Okay. Scanf percentage %d ampersand a of 2. It will go to the location, this location. Now I value will again incremented by 1. I will become now 3. 3 is less than 3. No, it's not correct. So it comes out from the loop. This way, if you increase the array size as 30, no problem. Only you have to increase here, as instead of 3, you have to mention here 30. Is there any changes in the program? No changes. Only the size of the array was 3 that we have changed, and the loop should run for 30 times that we have changed. Rest all remains same. Where in case of this, if the size is 3, 3 percentage days, 3 addresses I have to mention. If size is 30, I have to mention here 30 percentage days and 30 addresses. This was a tedious, and this is very simple. Usually we apply this approach for initializing the large arrays. Now we'll see how the tracing will take place. In our first pass, I value was 0 and 0 is less than 3. It reads the value in A of I, that is A of 0. First value will be read in A of 0. Second value will be read in A of 1, and third value will be read in A of 2. Now the output will be, it will ask me enter 3 values. I have entered 12, 34 and 15. First, it will scan this 12 and it will place it in A of 0. Second time, I value will become 1. 1 is less than 3. Yes, again, it will scan the second value and it will place it in A of 1. And increments I by 1, I becomes 2. 2 is less than 3. Yes, it will scan the third value 15 and it will place it in A of 2. Now I value will become 3. It will increment and it will become 3. 3 is less than 3. Condition fails. It comes out from the loop. Usually, whenever you make use of one-dimensional array, for reading, we are using one for loop. For printing, we are using one for loop. For perform any of the calculation, we are using one for loop. The for loop is basically used for this purpose. 0, 1, 2. The indexing purpose, we are using the for loop. Always the index starts from 0, so always all the for loops will start with 0. This way we are assigning 3 values, 12, 34 and 15 in the runtime initialization. Thank you.